Hi, welcome to Numero Studio. In this video, we will talk about a problem that seems to be daunting at first, but when examined closely, we will find that it's actually not intimidating at all. We just have to get out of the normal mathematical processes, a bit of creativity, and some critical thinking to solve it. So let's call this the impossible product. When we speak of a product, we mean the result of multiplication, as in the case of 2 times 3 equals 6. So 6 is the product, and 2 and 3 are the factors. So the problem goes, find the product of x minus a times x minus b times x minus c until x minus z. So notice that we are multiplying a total of 26 factors here, as the pattern makes use of the letters in the alphabet. So using routine mathematical processes, what we want to do is multiply x minus a times x minus b first, then we get a product, and then multiply x minus c, and so on until we get to x minus z. Now let's go ahead and do that. So when we multiply two binomials, we use the FOIL method. So let's distribute. X times x is x squared, x times negative b is negative bx, negative a times x is negative ax, negative a times negative b is positive ab. Notice that in multiplying those two factors, this resulted to 4 terms in the product. Now let's multiply the third factor, which is x minus c. We use the same distributive property, so we begin with x squared times x is x cubed. X squared times negative c is negative cx squared. Negative bx times x is negative bx squared. Then negative bx times negative c is positive bcx. And if we continue the rest of the terms, we get to this product. Notice that there are 8 terms in the final product when we multiply the 3 factors. Now, if we multiply the next factor, which is x minus d, notice that we will get 16 terms. So indeed, it looks like we are dealing with an impossible product here. However, if we look closely into the pattern formed by the factors, we will get to a factor that says x minus w, x minus x, x minus y times x minus z, right? Now, I hope that you have noticed a very interesting factor here, which is x minus x, which is equal to 0. Now, we know that when 0 is multiplied to any number, and in fact any algebraic expression, the result will always be 0. So see, we just had to be a little more creative and depart from the usual routine processes to get to this desired result. So I hope you learned something in this video. Thank you for subscribing and hitting that notification button. I'll see you in the next one.